Say you want AI to generate market segments for our food fulfillment and 3PL routing platform. This part is a descriptive prompt. Now, let's ask it to identify the platform's capabilities first, then map those capabilities to specific customer attributes. This part is a directional prompt, because while we're not calling out a physical direction, left to right or right, capabilities as a word has an implicit relationship with our food distribution app.
All right, so these are our results. Our app optimizes truck mix to minimize cost. This is good for customers who operate more than 3 fulfillment centers. Our app optimizes across many constraints, which is good for companies with lots of constraints like mid-market 3PLs or CPG food brands, regulatory weight limitations, and also companies with thin margins. And our app considers perishability, so good for companies that ship perishable items. So this is good for step 1. Now let's move on to step 2. Okay, so this is our step 2 prompt, and you can pause the screen and read it if you want. But it basically says, instead of looking at surface info like company demographics, headcount, etc., look at and list variables in the distribution business that dictate how a company experiences supply chain friction, and make sure they're variables that have to do with moving, processing, tracking, and storing. So let's take a look at our result. Okay, so we've got a bunch of these here. So what I'm going to do is just create another output with just the names so that we can see all the names at once. Okay, so again, these are variables, and customer companies sit somewhere along the range for each variable. We're using these to build market segments. So we have SKU decay velocity, which means a company can be somewhere in the range where they have items that are very perishable or not perishable. Number of temperature zones, they're somewhere in the range where they can have a lot or a few of temperature zones at their facilities. Node network topology density, they can have densely clustered network nodes or widely dispersed nodes. Scale, they can be a large or small company. And skipping ahead, labor elasticity, they can require more labor to scale or less. Okay, so that's obviously a large amount of variables to use. It's 20 some variables, and if we did combinations of high-low for each of those across the board, that would be millions of combinations. So what I decided to ask for from Claude was, for each variable, is the variation in that variable that exists in the marketplace wide enough for us to use it for segmentation? If we ask that question, then that could get us down to 7 or so variables, which is enough to create, maybe about 8 or 10 segments, a manageable number of segments. So, and what it came up with was that we need only about 7 of these variables. The items below that are redundant. Last mile capacity tracks node density. Thermal zone complexity follows commodity type. So we have successfully brought this down to 7 variables that represent friction for our customers. Right, so the next thing I did was step 3, which is to go in and create a matrix table, or really it's just a table at this point, where we can see all the different combinations of our variables. And then what we're going to do is use those, compare those to our customer attributes to come up with our segments. And it created a beautiful spreadsheet for us with all of our variables here, and we have every combination of the 7, right? So now what we can do is find some way to loop through this and see which of these combinations apply to which of our customer attributes that we identified in step 1. Okay, so zooming up to the top, remember our capability to customer attribute mapping, MILP, order node assignment, which is our algorithm, is a capability of our app. And then the customer attribute that would, address operates 3+ fulfillment nodes, currently uses manual or rules-based assignment. We've got another capability for multi-constraint optimization, has genuinely competing objectives. So these are our customer attributes that we derived from our product capabilities. Now we're going to write a prompt, just say a summary for each customer attribute. And what that did was that brought our count down to a manageable level. So our variable combination 1, 2, 3, 4, 17, 18, 19 from our Excel spreadsheet all directly map to our customer attribute, which is network assignment complexity, right? All of these variable combinations map to this customer attribute. All of these variable combinations map to perishability and time pressure. All of these map to volatility, disruption, and exposure, and these to margin sensitivity to optimization. So then I asked to reproduce the summary and also list our not considered relevant variables for each of these customer attributes. And what we're going to do is cross-reference those, and you're going to see an output here. Okay, so what we have here are actual segments. First line, first row, I combine all my variables that apply to my first customer attribute, network assignment complexity, with a single variable that is not relevant to network assignment complexity. That variable is skew decay velocity. Let's look at the summary of what that creates in C3. Dense network plus complex mixed orders plus large scale combined with fast decaying product means assignment decisions carry a time penalty on top of pure optimization difficulty. And then under that, we have our company description. Think a large multi-node fresh grocery chain. Assignment complexity and spoilage risk compound each other. That's a segment. Column D. The same dense, complex, large-scale profile, but with shelf-stable product, means assignment complexity exists purely from network and order breadth. There's no clock forcing urgency. Underneath that description, I see another company description. Think a large mixed category retailer running bulk dry goods through a dense multi-node network. These are actual segments, and we have about 36 candidates. So next, I'm going to pull them into a list and see if I can generate a list of companies within each segment. Okay, and I have a result. So I have 36 market segments for my B2B food distribution app. And we see some things we recognize: time critical dense network assignment. They're organized by our customer attributes: stable multi-node bulk assignment, dynamic spike driven network assignment. And over here to the right, we actually see real companies: Kroger, Whole Foods, Walmart, Instacart, Costco, Sam's Club, CNS Wholesale Grocers, real companies that would fit into each of these segments. So these segments are flexible. In the real world, we would probably consolidate them further. So take our network assignment attribute and combine it with our perishability attribute, and then create more targeted segments. Right? We can do that. But you see how this works, and you see how powerful our prompting can be when we use descriptive prompts along with directional prompts.